This could be good shit. Let me get it. Beep, beep. You, get out of here. Bother me. By the by, very quickly, if you like Mountain Dew and you hate that it's so freaking full of caffeine and shit, there's this thing, it's Olipop. It's called Ridge Rush. I'm so happy I found this. I'm very sorry. I used to drink I worked at a hospital, at an urgent care center, and I would down like 2 or 3 Mountain Dews a day. And I'd go home, I'm like, why is everything shaking? This just hits that, oh my God. Anyway, sorry. I have no stock in this company. I kind of hope you don't buy it, so there's some more left for me, but just so if you want to know. Okay. So the region exists. If I look at this, somebody has already chosen how to look at it. The whole idea of switching the integration is, I want you to look at it the other way, right? I want you to take the region, and you can take the region because of what this person did. They didn't show me the region, those jackasses. They just gave me, I'm like, oh shit, I gotta redo the region, and then I can try to switch the integration. Can somebody tell me very quickly what's the main reason you might want to switch the integration in the wild, like not just because they said to? Is there a reason why you would want to switch the integration?
Isn't the functions are really ugly?
Yeah, if the function inside, if the inside was cosine y squared and the dy was inside, I can't integrate that. I don't have the y for the u sub. So if you switch it, maybe that shows up. You guys we've seen that happen. We've seen that shit happen. Are you guys all with me? So there is a legitimate reason we might want to switch the limits, the integration order, from what it is to a better order. So this is just saying, hey, you don't even know what f is. Just can you switch this just in case you need to? If I want to plot this, what do I know for sure is doing something? What do I know? Like, there's no question. What is this variable doing? Which one? X is going from 1 to 3. Let me see if I can improve my... No. All right. I don't know. And then Y is going from this line to this parabola, right? Is that where I'm going to hit trouble? That's where I'm going to hit trouble. So change this. I'm trying to do this on the fly. Make this. All right, sorry guys. Everybody stay with me. I'm trying to make one up on the fly. Make this 2 and make this plus. Make this 2 and make that plus. Okay, I think that should help out a lot. Okay. So when I go to graph this region, how do I start to graph this region? I have to draw 2 walls for dy, correct? And the ones on your test, I kind of sat with and developed so that they would meet at both ends. So it's a little bit easier to kind of draw and know when you hit the end. This is a little more open-ended because I made it in like 20 seconds. I've got to draw my parabola, but I only care about the parabola between 1 and 2. So what can you do for yourself? Plug a 1 in, plug a 2 in. So a lot of you guys are trying to draw the whole thing, and it was getting you messed up because you weren't sure where to focus. The minute you've got your outer interval graphed, that's boundaries. Don't go beyond this. So when I plug a 1 in, what do I get for x squared? That's crazy. When I plug a 2 in, 4. And my other wall is going to be this line, and when I plug a 1 in, I get 3, and when I plug a 2 in, I get 5. So this would be the region, yes? Now, there's a reason I didn't give you this one. Now, this is not a good... Let me think, how can I save this poor little dude? Oh, if I just do that, that would save it. Okay, here we go. Let me change here. Let's start it. All I got to do is this. Yes, that'll make it work. Okay. Real quick. The reason this would be really horrible is, do you see how as x goes from 1 to 2, as x goes from 1 to 2, y goes from this wall to that wall. Yes? Is that cool? No question. Everywhere. Any x you pick, y goes from that wall to that wall, that wall to that wall, that wall to that wall. That, what I just drew in, I've drawn in lecture before. It helps you out a ton if you do that. There were so many mistakes that would have been stopped if you would have done that for yourself. It seems really simple. I'm just drawing lines, but what am I really doing? Which wall does this variable start at, and where does it end at? Yes? So this way would have sucked. If I said y goes from 1 to 5, x goes from this wall to that wall, but here it kind of changes walls up here, yes? And I didn't want to make one that horrible. So if I just make one change, if I just do this, 1 to 2, 1 squared is 1, 2 squared is 4, that's crazy. 1 times 2 is 2, that's amazing. And 2 times 2 is 4, so now they meet there. It's a little bit closer to what you guys had. Let me stop for a minute. Do you see how I used inputs from what this told me in the functions I gave you? So for some of you guys, it seemed like you weren't sure how to tell where things were. That's how you tell. The outer integral gives you the inputs you want to use. And then you can set up for each function, each limit, you can set up the wall for it. And on your problems, they should have met at both sides. It just makes it cleaner. So if I want to switch the integration, so now I want to be dx dy. What's the outer integral going to go from to? Good, because my y is going from 1 to 4. And now my inner integral, I can't just write the freaking same functions. I can't, and I definitely can't just put x squared to 2x on the outside. That makes no sense. So if I, this one says, get the area, get the integral of this as a function of x. So I pick a y, and I figure out what the area is. That's what this inner integral means. This inner integral is, if I pick a y, get the area, pick the next y, get the area, pick the next y, get the area, it's now going to be a function of x on the inside. So the inner integral is going to be the area as a function of x. So if I integrate all those areas together, I'll end up with the full scan of the whole region. So now I need the inner integral to be a function of y. And then the last thing I do is I actually put in the specific function values of y, and I get all those areas added up together. So if f is 1, I get the volume. If f is something else, I get mass or whatever the hell it represents. So my inner integral has to be functions, but what do they have to be functions of? Y. X is a function of y, because the inner one's got to be what x is doing. X equals something to x equals something. Because this is y equals something to y equals something because it was dy, correct? Okay. So let's label the walls. This wall is 2x, this wall is x squared. So what are those walls now in terms of y? X equals 1/2 y, sure. And then this would be x equals, square root of y. And I know it's positive because it's on that side. Yeah. And that was part of the issue on the on that problem number, what was it? That last one on the front page? Problem number 3, yeah. One of them had like radicals in there, and some of you guys, do you see how y equals x squared has both sides? If I drew a full y equals x squared, doesn't it have both sides? And when I take a square root, I need a negative square root and a positive square root. So I don't need a negative if I have the whole parabola. So you don't have to write negative y squared, for example, because y squared is both sides. So what do I put here on this inner integral? Now here's how I do it. Pick a y. Pick any y you want to. Where am I at? Yeah, 1 to 4. Oh, I still have the same problem, don't I? You almost did good, Jeff. Screw it. If I would have started here, it would have been great. Just pretend I did. If I pick a y, I go from this wall to that wall, yeah? So ignore this bottom one. I should have made it better. So what is this wall here? 1/2 y. So I go from 1/2 y to square root of y. So the ones you had shouldn't have been that evil. I try to make it so that it met at both sides, so you didn't have this weird double. You have to do 2 double integrals to truly do it. Yeah. I don't know if that makes any more sense, but that is what you're doing for yourself. When I'm drawing those little dumbbells, they look like old school barbells with the balls on the end. Yes? When I draw those in, I'm just seeing from what limit to what limit. So I'll make sure I get those in the right order. So a lot of you guys, number 3C, your inner integral was in the wrong order. Yes, maybe? Okay. So let me see. Let me play around for a second. Yeah. Yeah, here we go. Okay, perfect. Down 4 over 2 says. Will that work? Yeah, okay. So, let's say I've got this region here. So I want to integrate this where d is bounded by 4 minus x squared, y equals 4 minus x squared, and y equals negative 2x plus 4. Can you guys just take a moment and graph those? Now, does anyone know what's a really good first step before you just full out graph those two in the xy plane? This has got to be bounded by those two, yes? So what's going to tell me where to start and where to stop? Where those two meet. So an excellent first step is just set them equal to each other. Yeah, go for it. So let's do the algebra first. Set those two equal to each other. Let's see if Jeff made a good problem or not. Did anybody else come in and not get their test back yet?
Is this to the sixth problem?
No. We can talk about that next if you want to. This is still related to problem 3, believe it or not.
Oh.
So let's see, if you set them equal to each other. Oh, here's all my scribble making the problem. So if I add x squared and subtract 4, I get that. And then you factor it, and so you get 0 and 2. Is that cool? You guys kind of with me? Now, I didn't give you a problem like this directly in the test. I sort of did. That's like number 6, Dan. I think that's where you had to set them equal to each other. So that was a bigger idea. This one's just living in the xy plane. But now, when I go to graph these things, I have a much easier job. I know what these stupid things look like, correct? Can somebody tell me what that looks like? Be more specific. Down. Beautiful. Down parabola. What's that one look like? Negative slope line, yes? Cool. So I just need 2 points for both of them, yes? So what am I going to use? Frickin' 0 and 2, because I know that's where they are contained, yes? So here's my 4. So at 0, this is 4, and that's 4. At 2, this is 0 and that's 0. And if I really wanted to, I could plug a 1 in and see this is 3 and that's 2, yes? So this, when I plug a 1 in, this is 3. And when I plug a 1 in, this is 2. So there's a straight line and my parabolic arch, and I get my little banana. But no chicken. Too bad. Now, I've got a choice of how to scan this region. Yes? So this is what I mean. I think you guys get confused if a choice has already been made and you feel like you have to adhere to their choice so much that some of you guys took the variable with you to the outer interval. That cannot happen. So what are my two choices, of course? Yeah, is it going to be, let's try dx dy first. And what would determine the better way to go, if there is a better way? The most obvious thing that would tell me which way to go would be f, whatever that function is. You with me? Because again, maybe f is freaking cosine of x squared, so this wouldn't be the right way to do it, because I could not do the inner interval then. Yes? So the choice you make about dx dy versus dy dx, most often is based on what the function is inside. I didn't tell it, so it doesn't matter. So help me out. Which one can you just throw shit down on? The y. Y is going from where to where? Yeah, across this region is going from 0 to 4. Now, real quick, is everybody really cool with the fact y is going from 0 to 4, but do I want to count that point? Do I want to count that point? Isn't that 0 to 4 for y? But that's where x comes in and narrows our choices down. So y is from 0 to 4. Yeah! And then x comes in and goes, no. No. If I pick any freaking random y, I go from this wall to that wall. Yes? So what must x go between? Let's identify these walls. I should have done that first, but this was the parabola. Where'd it go? Y equals 4 minus x squared. And this was the line, negative 2x plus 4. I don't know why I took it way the hell over there. But now what do I need for this one? Do it again. Sorry? Yeah, so this is what y is doing. This needs to be what x is doing, yes? So this wouldn't be too bad. All right, let me make sure you guys are with me. If a region exists, I could choose to do it dx dy, dy dx. I do not get the choice to make this outer interval dependent on a variable, because if that's the last thing I'm doing, my answer won't be a number. Do you guys understand that there could be situations where the answer shouldn't be a number? Maybe you do want the outer interval. But like I said, not for us. We're getting numbers. You with me? So the outer interval must be based on constants. Okay. Because that is the last thing you're going to do. If it has variables, you can't get rid of that variable. It's going to be there at the end. So let's see. What does this become? X equals... If I subtract y, add 2x divided by 2, I get 4 minus y over 2. Is that cool? Which you could make 2 minus 1/2 y if you want to. It doesn't matter. You guys with me? Okay, because this has to be what x is doing. So x is going from 4 minus y over 2 to this, which will be what? And it's positive because it's on that side. Now, I left for you the easier one. Can you guys redo that, but the other way, dy dx? Reset up the interval, but dy dx. Oh yeah. There's no way. Somehow me hand these out. So the outer one is always the nice dude. It doesn't care. It could be whatever the hell it wants to. It's the inner one that has to really make sure we stay. So the outer one kind of like does a general stay in this area, right? Stay in the backyard. And then the inner one says, yeah, but don't go to the shed and don't go over there and watch all those bees there. It kind of like restricts further in that. You with me? I don't know if that makes sense. It's a very interesting way to look at it, but stay away from the bees. Okay. So what's the outer integral going to go from to? Holy shit. So that slices this off. So far I could be anywhere I want to be between 0 and 2, and then this guy, the inner one's like, no. So if I pick, so who thinks he got the inner integral set up correctly? This one's not that bad. What's your lower limit? Yeah. So if I pick a value of x, any random value of x, it goes from this wall to that wall. It goes from the line to the parabola. So this would be 1 minus x squared. Okay. You guys at all with me? Is this okay? So a region exists, and I can choose to scan it one way or the other. If somebody's already made a choice, that kind of sucks. I recreate the region and then sort of start over. Yeah.
When you're picking like the inner integral, you always go from like the lowest to highest, correct? So if it's on like on the left side, would it flip?
How do you mean? Oh, no, it's still the lowest to the highest.
Okay.
So like, just so I don't have to actually make a real one. If I had a function, let's say it goes like this here, right? And let's say this is f of x and this is g of x. Yes? Then if my, this is y equals. So this would be, let's say this is -1 to -4. Is that cool? And that, of course, is what x is doing. And what's y doing? It would be going, so if I pick an x, y is going from this wall to that wall. Now, if I do it the other way, then x would be going from, so here, x goes from here to there. Here, x would go from here to there.
Yeah.
I always want to go in increasing that.
Right.
Yes. Now, you all know the integral of a to b is equal to the negative integral from b to a. So, remember that? If I switch the limits, I get the negative area. So, I mean, somebody could switch the limits, they have to have a negative. But if I'm setting the damn thing up, I'm going to go forward. Yeah, I'm not going to go backwards and freak myself out with some extra negatives. Does that make sense? Okay. All right. Okay. Any other specific questions or general questions? You can make corrections like always. You can come see me for help. You can even, if you get the corrections done, you can give them to me and say, hey, Jeff, I'm not turning these in. Do these look all right? And I'll tell you if they look all right. It's crazy. And then I'll let you redo those that don't look yet correct. Okay. Today's lesson involves switching up a bit. Looking at number 6 real quick, because you had sort of almost asked a question about number 6. Number 6 was another favorite. Really, if you look back at number 6, the input plane is the YZ plane. How do you figure out the shadow in the YZ plane? That would be the D, the region in the plane, yes? So I kind of like the books, even though the letters don't necessarily mean much. E is the whole region in the three-dimensional object. D is the shadow on whatever the input plane is. So if you look back at number 6, if you turn your paper, the whole thing's kind of hovering over the YZ plane. This thing is a function of Y and Z, and this thing is a function of Y and Z. So what inputs do I need So let me look at pictures. It's gonna be, oh shoot. Oh, I did. All right. I just randomly chose a version. This is the one that's a little tiny dude. Some of you guys have bigger dudes. Some of you guys have a little tiny. This looks like a fishing bob or something. Okay. If you rotate it, does everybody agree that this point in the YZ plane has an output? It looks like, for example, right? The origin has an output. This point here has an output. This point here seems to have an output. Yes? So my question is, in the YZ plane, how far do I have to go out so that I capture all the points that are on this? Does that make sense? My shadow, my D region in the input plane has to be the region that contains all the inputs that have outputs. So if I really zoom in on this weird little thing, I think somebody saw this UFO up in the sky. I don't know, this didn't really translate too well, but it's okay because it was an extra little thing I was trying to do. See around there is a little green. If you could find the shadow of that, that would be the D region in the YZ plane. Yes? All makes sense. Hold on. Sorry. Make this guy go away. Stop. Okay. We did a couple problems at least like this. So a decent number of you guys understood what you had to do to get this. This is, of course, where the two things, this rim is where these two surfaces do what? Where they meet. This poor little sentient ice cream cone. Okay. Ah! So I must do what with these to discover that region, set them equal to each other. That is going to tell me the inputs that give that ridge around there. Now, will it always work that way? No. If one thing was a cone and the other thing was a cone, finding the little thing in the middle is not going to be enough to get all the points on the surfaces. Do you see what I mean? So this is a very specific kind of problem, but I wanted to give you this because we had done a couple like this, and I don't say that to make you feel bad if you didn't get this right. But that's what you want to do here. You want to set those equal to each other. Then you can figure out, that tells you what that region is. And then you've got, now, can somebody tell me the inner integral? What letter should it be related to? Should be related, yeah, dx. Should be related to dx. I'm sorry. I'm zoomed way the hell in. There we go. So we did stuff like this before too, and I wanted to, because when you do these kind of problems, you guys all understand, does anybody agree with me that there seems to be a lot to manage in these kind of problems? Do you agree? There's quite a bit to kind of manage, or at least it feels that way. So I tried desperately to figure out, is there a way I can give them something that should work in most problems to kind of like separate some of the work out? So if you can figure out what plane your D region lives in, which is a collection of all the inputs that go to the points you must consider. Yes? In this case, it's where those two regions meet, because every point in there goes to a point on the surfaces. Then that will tell you dA is in the YZ plane in this example, which means the inner integral is dx. So now I can focus on two kind of separate things. What will the limits for x be? And what does my dA look like? What does that region look like? So you should have also, and some of you guys figured this out without drawing it, but if I were you, I would totally take this and just draw the YZ plane separately. And of course, if you set these equal to each other, some of you guys have a different version, so I'm not going to do this, but you'll get a circle of radius something. Yes? And then you can draw that in the YZ plane. You can then figure out which one is going to be just numbers, which one, but to be really honest, what should I convert to before I do anything? Polar. Everything's screaming for polar in this problem, just about.
Yeah, I'm not gonna bother doing y and zx to dA or the entire way through delta polar.
Okay, yeah.
It's just
So what does x go from to? How can you tell How can you tell who's on top? No. That's going to help you get this. My x's are going to go between these two surfaces, correct? X goes from here to there or there to here. How do I tell which way it goes? Why?
Well, one's positive and one's negative. If you look at one of the planes, like the XY plane, and one of the parabolas will look positive, one will look negative.
Does it make sense this guy's going to open down?
Yeah.
Yeah. So he's the blue dude. So it should be from this guy to that guy. Yes.
About that, since they are identical, one just shifted in reverse to another. So what I did and kind of marked it down, but it's because I did a mistake of not multiplying it by 2. Can I just find where they intersect, integrate from lower part to this number, and multiply it by 2?
Oh, no. Well, in this case, no, because you're integrating x. Let me think. That is symmetric around there. No, it's not. Do you see how x is changing here?
Yes.
So what you're integrating over has a much different set of values
I
here
see.
than it does there.
I see.
That was the, okay,
I see.
I don't know if anybody else is with us. Stan saw something beautiful. He's like, the top dude and the bottom dude are basically the same thing, just one's been turned around. Yes? So it's like, why can't I just integrate like the red dude or blue and then double it? It's because I'm integrating x. And I really want you, I desperately want you guys. So along the red dude, doesn't x go from 0 to this, to the green rim? Yes? So it has values from 0 to the green rim. In the blue dude, x starts at the green rim and goes way the shit out there. So the integral values across those regions will be very different. It's not symmetric with respect to the function I'm integrating over. I don't know if you guys remember. That's a little talk I had. Remember it was like a rectangle and then I cut it in half and said, when are you allowed to double the integral? It was on the practice test? Okay, I'll let you guys. You're all a little overwhelmed, which is not where I want you to be, but it's Calc 3. There's a lot going on. I need you to be able to focus on parts at a time. That's what's going to help you through a lot of this. It seems to me like some of you guys are just trying to throw everything together at once, which is impossible. Does this make more sense, this problem, if you had trouble with it in the first place? The first thing that should jump out at you is the YZ plane is the input plane. So that means that's where the region D lives. That's going to tell me what my dA is, the last two parts, which means the x dude is the inner integral. And now we know it goes from y squared plus z squared up to 2 minus y squared minus z squared. Before I do any of that integration, I would change the polar. Okay, maybe I've done enough. Okay. By the way, I really want this to make sense, especially considering where we're going. Do you see how this inner one's dx? And this is going to be r d theta eventually, yes? But do you see how the inner one is dx? Is everybody with me? And you're all like, yes, Jeff, we see it. I'm not going to replace the x here with shit. It is x. It doesn't need to change. It's not a function of r and theta. It doesn't need, in fact, you can't make it a function of r and theta. It is x. It doesn't care about r and theta. Where do r and theta live in this problem? Where do they live? YZ plane, kick ass. So does x give a shit about the YZ plane? No. In fact, it's 0 when it goes there. It hates it there. You guys kind of with me? If that if that thing here was y or z, then I would have to shift it to r and theta because I'm changing y and z to r and theta. Am I changing x to anything with r and theta at all? Do you guys see that? You guys see the difference here? Okay. And what's really neat is when we get through some of today's lecture, I'm going to come back and show that this problem is actually using something we're talking about today. Okay. Whatever you say, Joe. All right. Anything else? I think. Oh, real quick. Number 4. Very quickly. Some of you guys had said y equals 0. What is y equals 0? X-axis. So if you had y equals 0, one of your boundaries should have been this. And then there's a line. By the way, guys, here's one thing I meant to do. Is there a difference there?
That's square root of 5 times 1.
Yes, cool.
Square root
Yes.
of 5.
So everybody had square root of 3x. And that is a line with a slope of square root of 3. Yes? I really didn't mean that to be tricky at all. I wasn't even thinking that way until I started grading. I was like, oh, shit. Just very quickly.
Trying to make it more clear, I get every single one of those.
Oh, yeah. Oh. So this is where I'm living, right? I'm on this circle in the first quadrant, bounded by these two, this, and this. Now, if yours said x equals 0, what is that an equation of? This. So some of you guys, this is the region. Some of you guys, this is the region. It just depends on where was the wall. 2 walls are definitely this circle and this line. If I say the third wall is this, that's your pizza slice. If I say the third wall is this, that's your pizza slice. Do you guys see that? Okay. How do I change this to r and theta, though? How do I figure out what theta is? Theta is very obviously, let's say it's, what is this one? This is this one. Does theta go to pi over 2? Pi over 2 would be here, right? But this is my region, yeah? So how do I tell where theta stops? What is the conversion between polar and rectangular that deals with theta?
0 to pi over 2.
No? So for example, x squared plus y squared is r squared. What's the conversion that deals with theta?
Theta equals y, or inverse tangent of y over x.
So in this case, what's tangent theta equal? Y over x is root 3, yeah. And I like that. I think at least one of you guys rewrote tangent as cosine and you kind of figured it out that way. If you forgot what angle makes tangent square root of 3, you have methods to get it. Don't go, I forgot. No, you have methods to get it. Now, if you forgot the methods, that's a whole other thing. But at the very least, you should tell that this does not go to pi over 2. It stops here, yes? It doesn't go all the way to pi over 2. You with me? I don't blame you. You saw the words first quadrant and you thought, okay, that's pi over 2. But no, the region stops right there. For those of you who had this pizza slice, your region starts at pi over 3. That's what this is. And goes to pi over 2. Okay. All right. I think that's everything I wanted to talk about. Yeah. Nobody asked about number 1, so there's a lot of different things to number 1. Again, the easiest way to do it is to set fx equal to 0, solve for y or x, and then plug into fy equal to 0. Because then they're already equal to 0, and you can see what makes one work and plug it in to see what the points are. So some of you guys got more points than should have existed. If you're not certain, if you get a whole bunch of points, just plug each one in real quick and make sure it makes both partials 0. Right? And you're like, it's easy for you to say real quick. I got so much time on this test, I'm sorry. But that is one thing you need to do, is before you do all this work to test them, make sure they're even something you have to test. Right? Okay. Anything else from the test before I go into today's craziness?
Unless we're going to go into 2 of it.
Which one?
2.
Oh, I heard somebody over here go, yeah. Just ask me, it's not a big deal. So, a remarkably pathetic attempt at graphing this. Here we go. Yes, and then I have one corner there, so I have this box. Beautiful, look at that. I had to make it tiny because it's horrible. Well, what's the volume of the box? Well, it's the box. my dimensions are, like we said earlier, x, y, and z. So the volume is, if I want to maximize something, I have to get a function of for something. So the volume is x, y, z. But it's not that free. Z is not its own, whatever it wants to be, correct? Z is constrained. So the volume is actually, in this case, all this business. And some of you guys had 81, I think, somewhere in there. Yes? You distribute that business. You take partials. You get the critical points. You check them. Yes? That's it. So, real quick. Here, just so I'm not doing people's work for them. Let's say I had this. Sure. Haha. So I get x, y, z. So I'm going to do x, y times all this. Is that cool? Just so I don't have to write so much. Everybody should be very happy about that. Okay. So distribute the x, y. Is that cool? X, y, z. Now I've got a function that represents volume. I can attack it with calculus to figure out its maximum. So this is in 180, when I said maximize, minimize, find the maximum profit, find the minimum cost, whatever. Get a function, take its derivatives, find the critical points, check, right? You did that quite a bit. So here's the same thing, it's just a ramping up. It's just calculus 3 version. So what's Vx? And I'll show you what I would have been cool with, by the way. I'll show you. You don't have to do all of it. What's Vx?
Y minus
3x squared y over 16 minus
3x.
y.
I like it. Do you notice each term has at least one y? So this is y times. Yes? So then one potential critical point would be y equals 0, but how do you know that can't be?
Volume.
That would make the volume. Screw him. Get out of here. Get out of here. Okay. That leads to a nonsense answer. Well, it leads to the minimum volume, right? Vy is going to be x minus, poor little dude. Blah, 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 blah. You can x out the same way. And again, this can't be 0, so I can just ignore him. If I set each one equal to 0, I effectively get a couple of ellipses. Now this is where, now look, all right. So let me see. What I'm saying is if I set each of these equal to 0, I'll get 3x squared over 16 plus y squared over 25 equals 1. Is that cool? Just add this stuff over and I get this. Same thing here. So now is when I pick now, do I have to solve for x or solve for y? Why do I not have to solve all the way down for x? Because nobody's got an x in it. Everybody's got x squared, at least, yes? So if I solve one of them, I'm going to solve for that squared. And then I can plug it directly in. So some of you guys got trapped in the solving all the way down. You got these disgusting looking things. You're like, oh shit, Jeff, what are you doing to me? I'm like, I didn't do it. So if I solve, it doesn't matter. What do you guys want to solve for? I'm going to solve this one for y squared. Is that cool? You do you, Jeff. All right. So I'm going to subtract this over and I'm going to multiply by 25. Is that all right? So I'm going to get 25 minus 75x squared over 16. Is that cool? Subtract, multiply by 25. And now you take this and you throw it in there. Now the numbers I picked for you, I picked to come out a little bit cleaner. Yeah. This will come out, let's see. This will be x squared over 16 plus 3/25 times y squared. Is that all right? I just replaced y squared with what it is. And now when I distribute this 3/25ths, it's really nice. That's as far as I'm going to go. I want you guys to have something to do. So you're almost there when you get here, because now you have only x's. You can solve for x, and then you can plug back into the other equation to see what y is for those x's. You get your critical points. Ignoring the zeros, because we know those didn't lead to anything good, I think you only get one valid critical point, if I remember correctly. What's it?
I think it should be 4.
Huh?
I think it's 4. It's symmetric. There's 4 of them across it. That's the same y value. It's the one negative one. It's just the negative zone.
By the way, I didn't say what octant should we be in to get the maximum volume?
First one.
Yeah.
It doesn't really matter. It's all. It's the same.
Yeah.
value.
So yeah. But the second and fourth will give you negative answers because x and y will be different signs and z is positive. Volume is x times y times z. So if x and y are different signs, you'll get a negative y.
It should be the same solid though, 3D, shouldn't it? There's
Yeah, but officially the x variable is negative in like the second quadrant.
yeah.
Right. It's sort of like if I have a triangle sitting above the x-axis, it's a positive area in calculus. If I have it sitting below the x-axis, it's officially a negative area.
Yeah.
Okay. Is that enough to help you with your specific problem? Okay. Now listen, this is not everyday math. But you're not in an everyday math class. So this is actually building on systems of equations. It does get a little bit freaky here, but if you just realize y squared is itself a variable, then it can solve just for y squared. There's no reason to drill all the way down to y and bring square roots in and freak yourself out. Okay. Okay. If there's no other questions, we're going to get into new stuff. Bonus 3. Everybody had the same bonus, if I remember correctly. Oh, this was if you did the Lagrange multipliers section, which I think I made. Where was that? That was 15.4? No. Was that further back? Yeah, it was 14.8, right? Yeah. So if you did not do Lagrange multipliers, you might not be able to get this. There were other ways around it, but is that okay, Sky? I don't know if you did that. Because it's all, Lagrange multipliers is all about applying constraints to a system. And it's got a really cool visual as to how those constraints work with the system, so. Okay. All right. So if you want specifics about that bonus, just ask me later. Okay. Let's get into the next two sections. So we're going to finish up chapter 15 is my plan for today. We'll see if it comes to fruition. So let me ask you this. Do you guys remember a cylinder in 3 dimensions? Can somebody give me a very basic cylinder equation in 3 dimensions? I mean, what is a cylinder? What is the standard cylinder? So in this class we learned that the word cylinder applies to any repeated shape. But in everyday life, if I say, oh look, it's a cylinder, what do you know it's going to look like? Yeah, repeated circle. A paper, the inside of a paper towel roll, right? Paper towel roll thing in the middle, the cardboard. You with me? You threw it in your hamster's thing when you were little. Okay, so a cylinder is a repeated circle, yes? So if I have a cylinder going around the z-axis, can somebody tell me an equation for that? If it's going around the z-axis, should my function care about z? If I move along the z-axis, should I get bigger or smaller or do weird shit based on where I am in terms of z? Because what's a cylinder fundamentally, or any prism really, but a cylinder is specifically a prism where the repeated shape is a circle. Yes? So it should not depend on how high up or low down I'm going along the z-axis. Yes? What's it look like in the xy plane? Circle. What's the equation of it? Let's say it's a radius 1 cylinder. That's the equation of the cylinder in 3 dimensions. So if I just repeat that for any value of z, it's going to make a cylinder, correct? Now, if I have a cylinder, do I really want to work with, in fact, we've seen this already, do I really want to work with x, y, and z? What's a cylinder screaming for? Polar, yeah. And the thing is, it's only going to be, here's a nice way to do x, y, z, so it's not too busy. Well, here. Yeah, let me give you this. This is going to take me a moment, okay? I didn't have time to staple these, and there's 3 sheets for everybody. So don't give anybody any of what I give you, okay? Sharing, in this case, is not caring about yourself, so don't do it. You should have 3 sheets. Oh, wait. 1, 2, 3. Like an interesting spin on a designated driver. Some of these work nicely with you. I'm pretty sure I warned you guys about this.
You did. You said it.
There's 2 new coordinate systems, but one of them is really not new. Oh man. Now throughout my math career, I've worked with probably at least 11 coordinate systems at one point or another, but some of them were slight variations than other ones, so I'm not sure if I would count them all. So there's a lot more coordinate systems that exist than the ones we're going over, but a lot of them, like I just said, are kind of variations on these main themes. The cylindrical coordinate system we've already seen. When we did that problem number 6, we made it cylindrical. Didn't we make the YZ plane our R and theta? And then wasn't the x-axis just itself? That's basically the idea behind a cylindrical coordinate system. So instead of me desperately trying to make pictures, I made a computer make some pictures. And there we go. I like this picture, it's kind of nice. So if I put an x here and a y there and a z there, this would basically be the coordinate system we used for number 6. I have an axis that runs along, and then I have the plane that it's perpendicular to is circular. And this axis just runs. So this works beautifully in situations like number 6. Okay, so you can see how it's a part of a cylinder. I've got my r theta is how I determine this, and then my z just tells me how far up to go or down. Yes? So it's that simple. We totally understand polar. If I want to get over to Kelly, I can just say, I'm going to turn so much, I'm going to walk so far, and now I'm adding in, and now I'm going to just fly in the air so much. Yes? That'll be my z-axis. Okay. So, I need everybody to really understand that cylindrical is something we've already seen quite a few times. They're just kind of formalizing it now. So there's all our basic polar stuff. Look at this. I mean, come on. That right there tells you this is not that big of a deal. Z equals Z. Okay, thanks. It's the XY plane that I'm making polar, and the Z I'm just leaving it alone, which is exactly what we did with number 6. Okay, maybe. So what's really, really funny, can somebody, without doing any work, tell me one part of the answer to this?
Z equals 3.
Yeah, 3. It'll be something, 3. Yes? That's going to be something, -1, because what's the formula to convert Z? Z. Okay. Now, how do I, real quick, just doing one of these. If I want to convert this, R theta Z, huh? Yeah, there you go. So this one's nice and easy. I don't have to do any real work to get the theta, right? Theta's got to be pi over 4. Is that cool? Z's got to stay the same. And what's R? R. Square root of 2 squared plus square root of 2 squared, square rooted. So that's 2 plus 2. Are you guys with me? How do I get R squared? I take x squared. What's x squared? And what's y squared? Add those together.
4. So it's 2.
Yeah. So it's 2, not square root 2. Okay. Say it together. That's the way it should be. And now look at on the second point. You guys see what's going to happen here? Can anyone tell me what quadrant in the XY plane we're in? Because the last dude I don't give a shit about. Actually, he's the best thing ever. So it's not that I don't give a shit about him, it's that he's involved 0 work. Because Z stays the same. It just means the height, which is what it means. There's nothing to convert. And whereas going X versus Y, I've got to totally convert all that shit. What quadrant in the XY plane is the shadow of that point?
2.
Yeah, I've got to go back and up. So that's the second quadrant. Yes? And to figure out what theta is, tangent theta would equal, well, y over x. Yes? More fundamentally. Because I got y and x, right? So tangent theta would be rad 3 over -3. I already know it's in the second quadrant, so I just need the reference angle. No, real quick, guys. The way I remember my tangents, what's on top of tangent is called? No, I'm sorry. Trig function. Sine. Tangent goes like sine. When sine's big, tangent's big. When sine is small, tangent's small. You with me? The tangent could be either rad 3, 1, or rad 3 divided by 3. That's the 3 big ones in the middle. And then, of course, it's either 0 or infinity, yes? Or the other way. Yeah. Or the other way, yeah. So here, I know I'm in the second quadrant. I'm going to work on that shit later. I just get the reference angle first. So at what angle will tangent be rad 3 over 3? It's smaller. It must be when sine is smaller. When is sine smaller? Even smaller. When is sine the smallest without being 0 amongst the angles that we have memorized? 5 or 6. Sine likes y. When is it small? When it's really far away from the y-axis? 5 or 6. But it's in the second quadrant, 5 or 6. Now somehow you got here and you never took any trig. Wow.
Good job, man. You got 2.
I know. Holy shit. You made it through Calc 2. You can't say you don't know any trig. Unless you're like, I get everything else right except the trig. And of course, how do we get R? In this case, it'll be a little bit worse, but yeah, 9 plus 3. 12 square root of 12 is, huh?
2 root 3.
2 root 3. You guess. All right, are you guys okay with that? If I give you just that kind of problem? It's all the stuff you already know. You just have to apply it, yes? Go ahead and do number 2 real quick.
Do you have extra paper?
Oh, yeah, sorry.
Thank you so much.
Here, I got your test also. Sure. Hopefully this feels very familiar to some of you guys. I'm out of here. And you can see how SOHCAHTOA sucks. If you remember, x likes sine, cosine and y likes sine, or the other way, cosine likes x, sine likes y. You remember what goes with what. They like each other, so it works both ways. What quadrant are we in? So I know that x should be positive, y should be negative. And sure enough, cosine of a negative is still positive, yes? So what's the cosine of pi over 4? 2, yeah. This negative, same stuff, yes? They're supposed to agree at 45-degree angles. And of course, what's Z do? He's awesome. Z is very chill. It's like, I'm just going to sit here while you do all that weird shit. All right, so that's not supposed to be difficult. It's just polar with a freaking Z. Yes? You just do polar, and then you allow yourself to go up or down. Yeah, like it?
3D fold.
Huh?
This is like 3D fold.
3D pool. And this is kind of like, I don't know if you guys remember, I can't remember if I talked to you guys about the circular parking, when you leave a parking structure, you go down, this, yes, you remember? So that's like polar, and then why does it keep repeating? Because if I introduce a z-axis, the fact that it repeats its position, let me make sure you guys have all been in the, how to get out of a parking garage, and it's just these, you know, okay. If I look from above, the car looks like it's just going like this, right? And that's the x squared plus y squared equals r squared part. But now, if you look from the side, I've introduced the third dimension, z. So it's just repeating the circle, but it's constantly going up or down based on which side way you're going. Does that make sense? So that's why z kind of stays the same, because it's not really affected by anything. It's just going up and down. Okay. Now we get trippy. Okay. So this really is just polar with a z stuck on, yes? Spherical is completely different. Spherical is a brand new thing, brand new. It's built off of polar, but it's a lot more to it. And so why the hell did we make it? Because certain problems become easy as shit if I make them go into spherical, and anything else they'll be difficult. Keep you up with that. So this is why you want to know more and more coordinate systems, because any specific problem you're looking at could be really difficult in any one you know, and if you just knew this other one, it'd be easy as shit. Yes? Okay. So you get to a point where you're like, is there a coordinate system? Like, this thing is insane. Is there one I don't know about that would make this easy? Alright. So here's the idea with spherical. It's completely different. It does not involve, so let me see. Tell me anything about a sphere. What is the one thing you need to tell me for sure? It's radius. And then you can tell me the center, but if you tell me the radius, I know what it looks like. And if you're like, I'm going to move around, like, great, have a fun time. But in order to understand the sphere, all I need is a stupid radius. It's got a radius of 1 centimeter. Oh, it's got a radius of 3 kilometers. Holy shit. You kind of with me? So it makes sense that one of our coordinates in our spherical coordinate system will be the radius. But the reason we don't use the letter r we use the letter rho, which is this one. It does look like a P. I'm aware of that. Okay. Well, that's the letter rho. If anybody's done any physics, you should have taught, like density normally used the letter rho for it. Yes? Where else is, it doesn't matter, Joe. That's the kind of the equivalent Greek letter. The Greek letter rho is kind of equivalent to our letter R in the weird ways that we do that. That is the true length of this. Now, do you see, I like this little dude. Okay. Do you see in the XY plane? Do you see that point Q?
Projection of.
I love it. Kick ass. Right? Where are my linear algebra people? He just brought back some trauma. I'm sorry. So that is the shadow, is another way you could say it, of P, the point P in the XY plane. Is that cool? So if you want to be technical, that's projection of it in the XY plane. If I just look in the XY plane, this is polar. Yes? Let me see if you guys are cool with that. The distance from the center to Q, we call it R. That's why I couldn't call this other dude R, because R is already that. That's its job. So this actually is, like I said, it's new, but it's still built off of polar. The brand new thing is how we define how far up to go. And the way we define how far up to go is the angle. So I determine, somebody tells me, go out, rotate by theta. Yay. This is where things get really weird to talk about. Come away from the z-axis by this much, and then go out so far. So the way I tell somebody how far up to go. So if by the way, this is acceptable to say either phi or phi. I've heard people say it both ways. I don't know which way I'm going to say it at any given point. I normally say phi. Because that's actually more like, that's the symbol we use for the golden number from Fibonacci sequence. Huh? 1.618? Yeah. Okay. Okay. If phi was 0 degrees, how would I move? Straight up. Kick ass. You guys see that? If phi is 0 degrees and you tell me, bro, I'm going to go straight up. Does that make sense? Okay. And if phi is whatever, I'm going to go by that much. Okay. So it's kind of like you start on the z-axis, and you can think of that. This tells you how far to move away from the z-axis. And then down here tells you which way to kind of look, and then it tells you how far to go.
So if phi is 90, it's just polar.
Yeah, if phi is 90, I'm completing the XY plane. It's not polar because it still has a third coordinate.
Yeah.
But yeah, you're right. It's effectively polar. Let me stop. Does everybody sort of see what's happening? By the way, before I forget. Well, actually, it's coming up. That's right. Okay. The next part after we introduce cylindrical and spherical is to talk about what do these look like in triple integration. Because what was it about triple integrals that I had to be careful about which coordinate system I'm in? Which part changes? I mean, which part really fundamentally changes? I mean, the limits will change based on R and theta, whatever, but it's the dV or the dA part, depending, yes? If I'm in polar, it'll be R dr d theta, right? If I'm in cylindrical, it'll be actually the R dz dr d theta. Okay, we'll see that in a minute. So if I'm in, and real quick, why is that R there? If I go from dx dy to, so dx dy, I go to R dr d theta. Why is the R there?
Because the angle does not tell you the length, because you know how far out you are.
So R times the angle gives you a length. So the area of a little region would be R d theta. That's the change in the arc length times the distance out, which is dr. You guys semi with me. So when I go from rectangular to cylindrical, that happens. What if I go from rectangular to spherical? Now we got some more issues. Because how many angles do I have run around spherical? 2. I got 2 angles running around. Yes? So they're both going to need some help. I don't know if you can see what D theta needs help. I have to multiply it by R to make it a true length. Now I've got theta and, what did I say? I was going to say phi. I was about to say phi. Is that what I said I was going to say? Phi? I say phi and phi interchangeably. I know. I always wait for the giant joke. Yes?
So do we need a DR only when we are not integrating from the zero? Like what's DR for then if our...
Oh, in spherical there's not going to be any dr. R is a middleman. Where does R exist for us? In the xy plane. Where does the surface exist? In the xyz region, yes? So R is kind of like a middleman. We're going to see in a minute what it does. In fact, let me just say this right now. Can anyone see what the relationship is between rho and R? Sure. So real quick, watch. If this is phi, let me see. This might not be the best picture to try to do this in. Do I have a different picture? Well, that's just as bad.
They're in the same...
Here. This one's not that much better. We'll get there in a minute. So, real quick. If this is phi here, this would be, so this tells me how far this went rotated to here. How far is this from the xy plane? Yes, pi halves minus phi. And this is a right angle. It's just tilted away from us, yes? Because this is coming straight down. Are you with me? And this is going straight back. This is the xy plane. This is parallel to z. Is everybody with me? And this angle is pi over 2 minus this. So this must be phi up here. So can anyone tell me? I have a hypotenuse of rho. Yes, in fact, let me try to redraw this. I've got, this is P, this is Q, yes? I'm going to draw this a little more facing us. This is rho, this is phi, this is R. What is R in terms of rho and phi? Yeah, if you look at it like this, R is the y side.
Cosine?
Huh? No.
Phi, sine.
So R will be rho sine phi. So that's what I mean by R is a middleman. R is not a part of the coordinate system, is it? But it does help me kind of like put myself into things. If I was in the xy plane, that's what we would call R. How do I kind of extend that? R is rho sine phi. Okay, let me stop for a minute. Do I have to know that right now? In fact, wait, do I even say that already? No, not yet. I sort of kind of talk around it. So here, let's talk about, oh, beautiful, perfect. I forgot I was doing this right here. This is perfect. Okay. Let me do this. Where'd I put them? Oh, the right. Get a clean one of these. Okay. So we know now R is rho sine phi. And I want to know what is x. If this is x, y, z, I want to know what x is. Oh my gosh, okay.
X is R sine theta.
So here's y, yes? And here's x, yes? And here's this triangle. I know this is rho sine phi. So let me draw this over. Can you guys kind of see? So this R is rho sine phi, yes? This is parallel to the y-axis. So this is the length of y to this point. Is that cool? This length is the value of y here. This length is the value of x here. Is everybody with me? So to get to this point, I would go x, y, z. I've already smooshed this down by doing this. Is that cool? You need to just see that. Isn't x a piece of this? And this is what real quick side note. I can't remember if I said this to you guys. If I know the hypotenuse and I multiply by sine, I get the amount that's on the y side. If I multiply by cosine, I get the amount that's on the x side. That is a shortcut to all the stupid ratios you make, right? If I know the hypotenuse, this isn't perfect, I'm pretty sure I told you this. I think of the sine of the angle to be the percentage of the hypotenuse in this direction. It's not really a percentage because it's not linear, but what the shit? It's between 0 and 1 if you just stick with the first point. And I think of the cosine as being the percentage that lies in this direction. So if this is 5 cosine theta, this is 5 sine theta. Yes? Okay. That's one reason why this. So looking at this triangle, let's redraw that triangle because when I have this Dorito chip laying on the floor, it's hard to tell what the shit's going on. So let's try to redraw this little triangle, dude. Where do you want to put it, Jeff? I don't know. Let's put it here. So here's my R. This is Q. This is the origin. Here's my X. Here's my Y. Let me be better. This is rho sine phi. R was just the middleman. This is Y. This is X. And this is theta. So, can somebody tell me what's X? Yeah, it's the hypotenuse times cosine theta. If you are completely cool with this being rho sine phi, then this should make immediate sense. If you weren't cool with this, speak up. I really hope everybody sees this. If you don't, let me know. Huh?
Well, because if you think about it just in polar, we have x is r cosine theta,
Yes.
y is that. So we just said, cool, now r is just.
So I'm just reformulating what R is.
Yeah.
So it makes sense that cosine still shows up for x because x lies cosine. So what's y? Rho sine phi sine theta. I understand phi and theta are a little close together in terms of what they look like. I'm going to try my best to make them look as different as I can.
Must be one has a vertical on it.
Yes. So this is why you don't, when you get to a certain level of math, you never write 0 like this. For so many reasons. 0 is a number, this is the empty set. It's also possibly phi, just written with an accent. Like, you guys, I love you guys. Part of this is just setting something up and then following where it leads. If I set this up, it leads me here. That's the only place it leads. Now the last thing is, what's z? Well, what's funny is, if I take rho and I force it into the xy plane, that's rho sine phi, so what's z? Yeah, rho cosine phi. Yeah, the sine piece is in the xy plane. The cosine piece is the z-axis. Okay, let me stop for a minute. Is that cool? Whatever you say, Jeff. Okay. And so, not surprisingly, we have our sphere equation here, right? We used to use r here, but now we know why we don't for spherical coordinates. This looks very familiar. Look at this dude. That just comes off of this guy, yes? So if I want to figure out, what time is it? Oh shit. If I want to figure out what phi is, so let's see, which one of these? Yeah, okay, here. Oh yeah, okay, beautiful. I was trying to remember what I did with this. So let's say I've got this, and I want to convert that to spherical. A really good thing to do is to remind yourself what you're trying to get. You're trying to get rho, theta, and phi. So just kind of You gotta remember that's the order it's gonna give it to you in. And again, I wish they would put the radius at the end of it. So getting rho is easy as shit, yes? I mean, computation, I mean, just algebra-wise, just word-wise, how do you get rho? Square them all up, add them together, and take square. Yes, it's just a good old Pythagorean theorem in 3 dimensions. Is everybody with me on that? Rho squared equals x squared plus y. So I'm going to get the square root of 9 plus 3 plus 8, kick-ass, which is the square root of 20, which is 2 root 5. Is it the square root of 20, Jeff? Yes, good job. I can add. So that's rho. How do we get theta? Same way I did with cylindrical. So the nice thing about spherical is xy plane is fundamentally still polar. So there's a lot of overlap. Yes? There's a decent amount of overlap. This is here. This just has one more letter in it. Yes? So you see polar in this. So theta is just going to be the inverse tangent of rad 3 over 3. What quadrant are we in, though? I want to go back and down. Yes, because they're both negative, yes? It's x, y, z. Back 3, down root 3, yes? And theta is in the xy plane, yes? So it'll be the inverse tangent of rad 3 over 3 on the 4th quadrant. Does anyone remember what the inverse tangent of rad 3 divided by 3 is? Sine is small when? Pi over 6, so it'll be 4th quadrant.
Negative pi over 6.
Sure, negative pi over 6. There you go, Stan. I was waiting. Or 11 pi over 6, kick ass. Either way. So I don't care which way you do it. So I have 2 rad 5 is my rho. Theta is, I don't care. Negative pi over 6 sounds good. And now I got to figure out z. I'm sorry. Phi. Yes. Oh yeah, why did I say 4? We're in 3. Thank you. So we're in the 3rd quadrant. We went over that whole thing and then I forgot. 7 pi over 6. We're pi over 6 past pi, so that'll be 7 pi over 6. Thank you back there. And then to get phi, I have to use this relationship, which just comes straight from the definition of z. Yes? So I have to build that up. What's bad about rho is it's like the square root. So it's going to be the inverse cosine of 2 rad 2 over 2 rad 5. Yes? And that is definitely not one you have in memory. I will need you guys to see this. So if I use this, cosine of phi is z. Z is 2 rad 2 over rho, which is 2 rad 5. So I get inverse cosine of rad 2 over rad 5, which you can just do in your old calculator. So be really careful. I mean, I'm going to give you, as often as I can, I'm going to give you angles you should know. If they give you an angle you should know, I don't want decimals, right? If you get this stupid thing, so this is a whole other level of trick. You have to understand when you should know it and when you don't. This is nothing you know. I don't know what angle makes that happen. Yes?
Wouldn't, based on the picture, would be because the sine is adjacent over the hypotenuse and cosine is opposite over hypotenuse and cosine is adjacent over hypotenuse. But the z is our opposite and our rho is a hypotenuse. So wouldn't it be a sine theta?
No. Okay. So if you look at it like this, this is better. I translated this into this one so you can see it better.
Okay.
Yeah. Okay. It's a little harder to see when it's over there next to the z-axis because everything else is happening in the other triangle. Yeah. I don't know. Is anybody doing that for me or no? You guys are like, what do you get?
0.886
Sure. Okay, so that's in radians, obviously. Okay, I like it. Okay, so in general, if I don't say just round to like 3 places, that should be plenty, right? And the preference is for radians. Cool. Down here, do these sound familiar to anybody? So, real quick. Do you remember in polar, if I had a cosine theta sitting there by itself, I wanted to multiply it by r, because then r cosine theta would be x. So what is secant phi? 1 over. So if I multiply both sides by cosine, what is rho cosine phi? Hmm? Well, what is rho cosine phi by itself? No. Z. So this is just z equals 2. So how would you do part B? Yeah, what you got? Not inverse cosine, just cosine, yeah? If I take the cosine of both sides, what's cosine phi? Well, okay, cosine of pi over 3 is, like you said, 1/2. What's cosine phi? Z over rho, yes? And what is, let me see, wait a minute, this one's a little bit trippier. Oh no, this one's the one that's got a little trick to it. Shoot, what was this one? All right, real quick, I want to show you why I noticed there's an issue. Am I done there? What's not quite right? Because I want to convert all the way to what? Oh, I'm being silly. What is rho? I want to go to rectangular coordinates, so I want all my letters, all my variables have to be x, y, z. So what is rho? Yeah, square root of x squared plus y squared plus z squared. So that is the equation, and I could like cross multiply and do all this kind of business. Now notice, if you cross multiply and then square, I get this, how much do I want to do this? This is kind of neat. So z over rho equals 1/2. If I cross multiply, I get this business. I don't know if you guys can see this. Yes. If I square both sides, I get this business, yes? Now notice, and then I get this business. So it's a circle whose radius depends on z. So if z is 0, what's the radius?
0.
That would be a point at the origin, correct? If z is 1, it'll be a circle of radius rad 3, yes? So what kind of shape does that? Starts at this point and goes up as circles like this. Cone, kick ass. So that is a cone. And can z be negative?
No.
Yes, it can, because I'm squaring it. So I have this cone going this way, and then I'll have this other cone going that way. It's like, okay, this came to mind. It's like a Darth Maul ice cream cone. Who's looking into it? Okay, sorry. That needs to work, but it just came out of nowhere. Some of you guys might know it's kind of like the, I don't know if you guys have ever seen the cone of time information going through time. This is forward in time, this is back in time. Anyway. Huh?
An hourglass?
Yes, sure. The great thing about that is it's all about time and information, and you can talk about it like it's an hourglass. Kick ass.
That's a big thing we do with conic sections.
Sure, conic sections, yeah, because then you can do this, and you can do this, and you can do this, and make hyperbolas and all kind of business, yes. But this idea, this picture is actually related to the flow of time, which is neat. Okay, Let me see. Oh shit. Oh, that's right. We go till. Yeah, I'm gonna let us out a little early, but not quite yet, because I'm an evil person. Just to kind of look at what we're about to do next. So here is what triple integrals and cylindrical coordinates. So what I want you to realize is, when we did number 6, our inner integral was x, so x was kind of acting like z. The stuff was all hovering above the yz plane. So it was just a normal thing kind of turned around. And so this was dx, and then r d theta was on the outside. Are you with me? That's based. So we already did cylindrical. Cylindrical is not a big deal. It's just adding one more dimension in, which sounds like a big deal, but it's just putting a dz there. That's what you do. So it's dz, r d theta, and r can go where the hell it needs to. And then you have theta going from something to something, r going from something, and then z going from something to something. So it's a little more. If I tell you it's cylindrical, most of the time I'm going to try to keep it with z going along the z-axis, but you could get some problems like the number 6 where it goes along the x-axis instead. But it's really nothing new. This is something we could have and did do before we even learned about cylindrical coordinates. But looking ahead, okay. Just to kind of show you how things get exceptionally trippy. And I love this picture because it always looks like somebody playing that game at the fair where you whack the thing, so it looks like a hammer coming down. Do you remember how we developed r d theta? I tried to draw a little three-dimensional volume dealing with r and theta. This is effectively the same thing. You could try to tease out. There's some old hits in here. Rho sine phi is here. Yes, that's this r. Are you with me? What we're trying to do in this picture is I figure out what dv is. Bless you. Figure out what dv is. In cylindrical, in rectangular, it's dx, dy, dz, or whatever order. In cylindrical, it's dz, dr, d theta, yes? r, dz, dr, d theta. That's important. So in spherical, I expect it to be a little bit worse, because now I have 2 angles running around. Yes? So what I want to do, well here, just to kind of show you where it does lead to. Now, why does it kind of make sense? There's a rho squared, because each one of these needs kind of like a multiplier. So rho d phi is kind of like the length in the z direction. Rho sine phi d theta is the length in the xy plane, yes? I don't know if you guys are with me. They each need a radius to multiply by them, so they're not just angles, so they're actual lengths. Arc length is s equals r theta. So rho squared being there makes complete sense. They each need a radius. But why is the sine phi there? Because one needs rho and the other one needs r. Rho sine phi. Yes, sir.
So this is like our r, dr.
This is what dv becomes in spherical. Right? You with me? So it is like r dr. It's like r dz dr d theta, but it's got rho squared, which makes sense because it had 2 angles, and it's got the sine phi because one of them wants to be with r. The theta understands r, doesn't understand rho. I don't know if you guys are real with me. Next time we'll get deeper into that. I don't want to say that phrase until I'm ready to let you go, because that phrase is get up and leave. So next time we will develop this a little better, and then we'll do some examples of this, and then we'll get into chapter 16. Okay. Oh my God. I have no idea.
Next week?
No, maybe. At the earliest, it would be next Wednesday.
It says on the schedule
Say again?
the 19th
What about?
is the next,
Next Wednesday. I don't know. Man, the end is approaching fast.
The world?
Yes, the world.